Some different trigonometric identities. Let's start with the ones that we know already. What's the magic word? SOHCAHTOA. Okay, what did SO stand for? Okay, sine of an angle. So you always start with the angle. Cosine equals adjacent over hypotenuse, and tangent equals opposite over adjacent. All right. Now, let's start with the. Am I getting these confused? No, there, I saw it. Okay. So each of these, I should have written it vertically. Each of these has a reciprocal function. Do you guys remember what reciprocal means? It means the fraction's like upside down. So it's kind of easy to say opposite, even though that technically might not be the best way. So the reciprocal of sine, they call it cosecant. Of course, they never spell it out, but that's what it looks like. Cosecant, the abbreviation is CSC. So cosecant of the angle would be equal to, instead of opposite over hypotenuse, it would be equal to hypotenuse over opposite. So it's just upside down. The reciprocal of cosine is called secant. So it's SEC. That would be hypotenuse over adjacent. And the reciprocal of tangent is called cotangent. It's equal adjacent over opposite. So it helps to remember it. You guys all have SOHCAHTOA already in your heads, right? So you just need to remember which one goes with which one. So the easiest of these is cotangent, right? Cotangent goes with tangent. These two, I kind of feel like are backwards because this has, cosecant has the co in it. So you might think it would go with cosine, but they're opposite. So it's, just remember these two are opposite, the sine cosine ones are opposite, and the last actually matches. So cosecant goes with sine, and secant goes with cosine. Anyway, another thing you could say is true, the sine of the angle equals 1 over cosecant of the angle. Okay, that's another way to think about it. Or you could say it backwards, cosecant of the angle equals 1 over sine. It's still a reciprocal thing. It just means you flip them upside down, they're equal to each other. Does that make sense? And that's true with all of these. You could write it this way, like their ratios are upside down, or you could just say cosine is 1 over secant. Secant is 1 over cosine. It's just their reciprocal functions. Okay. Next rule. Turns out that sine squared, by the way, when they do sine squared, for some reason, whoever decided this, they decided to put the square right there so it doesn't look like you're squaring the angle. And technically, they could have done it like that, but anyway, if they want to square the sine function, they put the little 2 right there. Sine squared plus cosine squared always equals 1. So basically it has to do with the Pythagorean theorem. Kind of works with sine and cosine too. Sine squared plus cosine squared equals 1. So we need that in our brains. I think this is the last one we need. Tangent is also, is equal to sine over cosine. because sine is like opposite over hypotenuse. Cosine is adjacent over hypotenuse. So when you divide them, you guys remember how to divide fractions? You flip and multiply. You guys remember that? Like dividing by 3/4, like multiplying by 4/3. So dividing by cosine is like multiplying by cosine flipped. And those cancel out. You get opposite over adjacent, which is what tangent is equal to. Anyway, it just works, okay? So, I don't know if this one will come up, but I'm going to go ahead and say it. So maybe you guys can finish this statement. If tangent equals sine over cosine, guess what cotangent is equal to? Cosine over sine. If you said cosecant over secant, did you say that, Shannon? That would actually work too, but you don't need to know that one. I'm not even sure, I'm not 100% sure they're going to ask us the cotangent one, but definitely need to know that one, definitely need to know this one, and definitely need to know these three. Okie dokie, Smokey. Got them all down. They're probably written in the, yeah, if you look at the green, well, they're kind of hidden in different places. Anyway, they scattered them around. One thing I need to point out, this right here, could look a little bit differently. Like if you subtract cosine squared on both sides, for example, you'd get 1 minus cosine squared. So sine squared is equal to 1 minus cosine squared. Or you could subtract sine squared to both sides and you get cosine squared equals 1 minus sine squared. You could even subtract the 1 to the left, you get cosine squared minus 1 equals, and then subtract sine squared over here. So you can kind of move these around in a lot of different ways. Probably it's going to be one of those three though. Yeah. Lots of stuff. Okay, so number 1, determine sine squared, cosine squared, and all that jazz. So the first thing we need is sine squared of 45 degrees. All right, well, do you guys remember the 45, 45, 90? What are the ratios of the sides? Legs? Okay, so what is sine of 45? Opposite over hypotenuse. Some of your calculators can do this, by the way. Okay, but what happens if I square that? What do I get? Right. 1 squared is 1. Square root of 2 times square root of 2 is 2. So it's just 1 over 2. That's the first blank on number 1. Okay, what if I did cosine of 45? Cosine is adjacent 1 over hypotenuse square root of 2. So cosine, in this case at least, is the same thing. So when we square it, we get the same thing. So sine squared is 1/2, cosine squared is 1/2. So in the third box, what's cosine? Sine squared plus cosine squared is going to equal what? 1. You guys see what they're going for here? They're trying to show you that this thing works. Sine squared plus cosine squared equals 1. Number 3. So 2 is a special triangle. If you have a nice calculator, it can kind of do it automatically. But you guys remember how to set up the 60, 30, 90? 2's a 60, so 1 Square root of 3, 2. So you could use that. If you have a nice calculator, it'll spit it out automatically for you. But remember, you have to square it though. And if you do it right, the sine squared and the cosine squared should add up to 1. So the third column should be 1 in all these. Okay, but the number 3 is actually easier because, yeah, there's no special triangle. You're just supposed to figure out what sine squared of 25 degrees is. So on your calculator, you'd probably have to do something like this. We need sine squared of 25, and let's go to 4 decimal places. What's that come out to? Okay, then we need cosine, same thing, but cosine of 25 squared. Okay, guess what those two added together make? 1. Are you starting to believe it? It's true. You don't believe it? Shannon, get out of the classroom. Okay, number 5, state 3 forms of the Pythagorean identity. Do you guys remember I said this thing was based on the Pythagorean theorem? Okay, so that's one way to write it. We kind of already talked about this. What's another way we could write this? Move stuff around a little bit. Okay, sine squared could equal 1 minus cosine squared, or switch them around. Cosine squared could equal 1 minus sine squared. Those are the 3 most common ways you would see it. See how it looks kind of like a squared plus b squared equals c squared. Okay, number 6a, it's the even I know. Cosecant is equal to what? We're supposed to write an answer in terms of sine or cosine. So cosecant equals what? No. Equals, I don't know if I erased it or not. Well, we're putting answers, that's true, but we're putting answers in terms of sine, cosine. You remember what I had, I erased it. Do you remember what I had written over here? Remember me writing this? Cosecant is like sine upside down. Yeah, because these two go together. They're reciprocals of each other, so you can just one of them. So this is like 6a as an example. Number 7. Show that each statement is true for acute angle A and its complement. Okay, so on number 7, it says sine of A. Okay, sine of A, so we're supposed to use that little picture on the right, that triangle on the right, would equal what over what? Sine of A, angle A, should be equal to what over what? What ratio does sine give us? Opposite and hypotenuse. What's opposite of angle A and what's hypotenuse? Side A is the opposite and side C is the hypotenuse. Okay, and then what's cosine of B equal to? Cosine gives us what over what? Adjacent over hypotenuse. So what's the adjacent? to angle B?
Oh, angle B. A.
Side A, and what's the hypotenuse? C. So sine and cosine of those opposite angles always comes out the same. That's kind of what we're showing there. You guys got it? Number 9, secant. Okay. What was secant the reciprocal of? What did it go across from? You guys remember? Cosine. Cosine is adjacent over hypotenuse. So secant must be hypotenuse over adjacent. So what's the hypotenuse? C. What's the adjacent to angle? We're on angle A right now, number 9. What's adjacent to angle A? B. Okay, and then the cosecant was what upside down? Cosecant was sine upside down. Sine is opposite over hypotenuse, so cosecant must be hypotenuse over opposite. What's the hypotenuse of angle? Oops, I'm on the wrong angle. Angle B is still C. What's the opposite of angle B? Side B. So they are equal. Just like sine and cosine of the opposite angles are equal, secant and cosecant of opposite angles are equal. Alright, now we're getting into the mess here. Tangent of x, here we go. Tangent of x equals secant over cosecant. Oh, this one is a mess. Whoops, wrong one. Okay, back towards the beginning I said tangent of x is equal to something. Do you guys remember what it was? There you go, sine over cosine. Okay, you guys see where we're trying to get to here? So, what is sine? What's the opposite of sine? Cosecant. So I'm going to turn sine into 1 over cosecant. And what's cosine the opposite of? Secant. Yeah. So it's 1 over secant. So far so good. The reason I did that is because I'm looking at where we're going. I'm just looking at that. Okay. How do you divide fractions? You flip the fraction you're dividing by and multiply. Right? I flipped this. What this is saying is 1 over cosecant divided by 1 over secant. So you flipped the secant, what was on the bottom, and put it on the top. How do we multiply fractions? You just do top times top and bottom times bottom. Kind of a mess, right? Sorry. Just gotta kind of play with it a little bit until you find out what works. Let's do some more examples. Maybe you'll get the hang of it. Sine and secant equals tangent. Okay, so we're trying to get to tangent. What do you think's happening in the middle of these two? Like if they're right next to each other, what do you think's happening between them? Yeah, let's multiply. you guys a little bit warm? I think I'm a little toasty. No?
Is your brain fried or is your brain fried?
I think you correctly right.
Dimension.
You guys want this one open?
Sure.
Why not?
Yeah. I'll work it.
Just long down. That should make you see. See how you're cold-blooded? Reptilian. Okay. So I'm trying to get this to equal tangent, and I'm remembering tangent is like sine over cosine, right? So I already have a sine here. Well, guess what secant turns into? 1 over cosine. So this one's really quick. This turns into sine of x times 1 over cosine. And what's sine of x times 1 over cosine? Sine over cosine, which is tangent. Do you guys follow that? Okay, all I did was I turned secant into 1 over cosine. And remember, if you're multiplying 7, you can just change it to 7 over 1, right? If you want to multiply by a fraction, you just put it over 1. So sine times 1 is sine. 1 times cosine is cosine. And that equals tangent. Having the time of your life. Are you loving it?
No.
What?
I'm gonna pull in. Is this gonna be on the test? Are you?
10 questions on the test. Yes. 20 for each of them.
Are you joking? Why me?
Because you're special. All right. 15. Secant.
Ooh, stop talking. I love you. Stop you.
So, even if you don't really know exactly what's going on, basically you just use all the transformers you need. So,
Transformers?
what do we know secant can turn into? We just did it up here. 1 over cosine. What does cotangent turn into? Cotangent turns into cosine over sine. Okay, what's going to happen? Do you guys remember how fractions work? What happens if I multiply these two fractions together? That happens, right? So guess what's going to happen here? I don't know what cosine of x is, but I do know that it will reduce with that. So I get 1 over sine. What's another way of saying 1 over sine? Cosecant. Which, guess what? That's what they wanted. Kind of hard, huh?
Yeah.
Way to go, Anya. How about you guys? Oh, number 10, we kind of already defined it. Let me help you guys with number 10. That's kind of a weird one. I kind of started off with saying that was one of the rules, that cotangent equals cosine over sine. So, I guess we weren't supposed to know that yet when we did number 10. So what's something else that cotangent is equal to besides cosine over sine? 1 over tan? And what's tangent equal to? Sine over cosine. And how do we divide fractions? The fraction you're dividing by, you flip and multiply. So 1 divided by sine over cosine is equal to 1 times cosine over sine. So in other other words, this equals cosine over sine. Which is what they wanted.
We could just do all of them.
This is crazy.
This is too hard.
Okay, you just gotta kind of play around with it until you find something that works. Everybody try number 12 and give you like 3 or 4 minutes. Let's see if you can figure it out.
That's not good.
Just do some transformations, see if you can end up with cotangent. Now that we've used this rule, we've proven this rule on number 10, you can use it on number 12. But just play around, try to transform the left part and see if you can end up with the right part. That's the goal. Start changing stuff and see what happens. What can those things change into? That's the first step.
Wait, so is,
On 12, I would leave the cosine alone. Just leave cosine alone, but I would change cosecant.
for,
Cosecant changing mix.
do we have to explain the cost thing? Or do we do cost equals cosine?
Like your last equals thing should be cotangent of x.
And cosecant, does that turn into like 1 over sine or just sine?
Cosecant is 1 over sine.
How many of these are? I think it was wrong.
10 except for 20 for you.
That's discrimination.
The test is entirely over this.
That's discrimination. I stand for you, Issa. Me?
This was all
I will not treat you this way. That is,
So
that is
is the
rude,
answer the
it's
works,
disrespectful,
I guess?
and it's not
Yeah.
appreciative of your
It's like
time.
the destination is the journey kind of thing.
Sure.
How do you know when you got there though?
Your support
Whenever that side equals to that
is the
side.
very
Oh.
best you can give the entire.
This last thing that is equals to is
Yeah,
What
I'm
they're
lost.
trying to
I
do.
don't know.
You should be an actor.
So is there,
Actually,
can you get sin squared or like sine squared on a calculator?
no. Well,
can you check?
calculator's not going to help with this part.
Bro. Oh wait, yeah, not the,
You think you got it?
Yeah. So very smart.
Yeah, you got it. Good job.
Yay. Did I get a medal?
wait, did I get it?
You get
I doubt I did.
Can I get a woman? Or a yard? I said a rule.
Yeah.
First two choices.
Oh, yay.
Is
you get flat butter.
cosine over sine?
Yep.
Yes. Did not think I would get there.
You got one. Yep. That'll work.
Hold on, good.
Technically, you should have started with what they gave you. You kind of skipped that step though. You just changed cosecant into 1 over sine to start with.
It reminds me of work at the pizza place.
I'm still doing it.
You kind of skipped a step.
How?
You have to replace cosecant with 1 over
I
sine.
mean, I did do that and I erased it.
You kind of jumped a step. Girls, you get an answer?
Yeah.
Bruh.
No, we
That's
didn't.
great.
We don't know how to do this. I need help.
Okay, what can, I lost my place. What can cosecant turn into?
I don't know why this kind of
Yeah. Normally, you want to turn everything, yes, that's first step. Normally, you want to turn everything into sine and cosine and kind of mess with it.
Turns into
You know?
sec.
Okay, cosecant turns into what?
Sec.
Oh,
You were in 60.
Yes.
I'm sorry.
So that's the next one, cosine x.
Wait, what?
wait, is sine divided tangent?
I could do 2. 2? Yeah, but it has to equal
Is
1.
that equal?
Yeah, so it's 30, 60, 90.
No.
I know, but you do 1, 2,
Oh.
square root of 3, right? Yeah, square root of 3 is a hypotenuse.
No, it is.
Yeah, I thought square root of 3 was the adjacent. No.
Secant.
There's a square root of 3. Square root of 3 is smaller than 2.
So
You're at what?
that is,
That might be a problem. Wait, no, but
what's tangent to?
if that's 60 degrees, 90 degrees across,
This two.
30 degrees. And this would be the biggest
How
side.
you get it
What
squared?
was I thought, but what
The
else?
adjacent side? The hypotenuse would be the biggest side. Yeah, so adjacent would be the smallest. So it's 1, 2, square root.
See where they wrote it.
Cosine over.
Oh! Yeah, see, that's how I have it, and it's still not equaling 1.
Then magic happens.
Okay, let me redo it and see what I did.
Can we have two
I had
No, we're almost done.
2 square root of 2, 2 over 3, and 1 over 3.
Okay, you're almost done. So, did you try and finish?
We don't know what's like this.
What's cosine times 1 over or 1 over sine?
Because think about opposite. They're on that angle.
Do I have to write the x's?
What's cosine
What?
times 1 over
Yeah,
sine? That's
The 60 degree. The 60 degree. Yeah, so the opposite.
Where did you get?
It's cosine.
Yeah, over 2.
Over.
Did I switch them around?
Hypotenuse is 2.
It's no, that's right.
Square root of 3.
It started with cosine times cosecant. This turned into 1 over sine. What's this times this?
2. Square root would be 4.
Cancel out?
Well,
And then
can't reduce to anything lower than 1.
yeah, that's right. So
Cosine
and
times,
then there's number 4.
when they cancel out, they're just reducing to 1.
Oh.
So it doesn't really need to do that. So what's cosine times 1? What's 1 times sine? And what's cosine over sine equal to? What we just did on number 10.
It's
Cotangent.
yeah.
Okay, that was 12. Okay, 14, you need to transform both of them. So what's cosecant turn into? 1 over sine. What's tangent turn into? Sine over cosine. So you're supposed to multiply those together. Why don't you guys give that a try? Yeah, it's a weird one. Did they slip one by me?
Wait, which one? Which one are we doing?
14. 16, you gotta just, tangent squared would be like sine squared over cosine squared.
You're hating. Haters gonna hate.
Yes,
I'm just gonna
that's my job.
check it out.
We could be famous
Like-
singers one day and you will regret that.
Yeah. I am not gonna give you free tickets to our shows
Bummer.
that people are gonna make millions of dollars to go to. Taylor Swift is gonna do collab with us.
Yeah.
How old would she be at that point?
She'll shut you all down.
You're just hating.
I am hating.
Jealous. Jealous.
I'm not jealous.
Alright, any luck on 14?
Yeah.
14. Main.
Okay, what's 1 over sine times sine over cosine equal to? What's going to happen when you multiply those two? Cross out. So it's 1 over cosine. What's 1 over cosine the same thing as? The other one, secant. Which guess what?
Wow.
That's what we were trying to get to.
Boom.
I don't see how you did that.
Okay, number 16. So this one has a little bit of a new idea because it's tangent squared instead of just a normal tangent. Anybody want to guess what tangent squared is equal to?
Sine squared.
Oh my goodness.
I totally do that.
So if that's true, guess what secant squared would be equal to? So it's just tangent is equal to sine over cosine. So if it's squared, that's just this whole thing squared. What would secant squared be equal to in that case? You guys remember what secant was the opposite of?
1 squared.
1 over cosine squared. You could say 1 squared too, but that doesn't really do anything. Okay, how do we add fractions to add a fraction to something, what do we need? Like if I was doing 3/4 plus 5, how do I, well,
5 would be 5.
And then you do
4 times 5 denominator.
okay, if it was like 5 and 1, or 5 and 1/5 plus 3/4 or something, what do we need here? Common denominator. Well, how do I turn 1 into a fraction? 1 over 1. What's the common denominator going to be between these two? Cosine squared. So if you multiply the top and bottom by cosine squared, you get I know I wrote a lot, but I barely did anything. What did I do? Turned 1 over 1 into cosine squared over cosine squared. What are these two added together? Kind of forgot where we're trying to get to this. Okay, shh. Oh, sorry. This part we're not supposed to know yet, my bad. We just need that part, sorry.
No, I was just about to write it.
I forgot the equation, we weren't supposed to know the right side of the equation yet.
Oh my gosh, wait, no, it's supposed to have. I need to remember this chapter.
I know, it's cruel and unusual. You definitely need to know like how to solve a right triangle, the area formula that we learned on Friday or Thursday.
And when it's been pretty easy, like
And some
the last
vector
few
stuff,
days
too.
really hard, and I have no idea what I'm doing.
Just today's the hard one or
Yeah,
Friday?
Friday's is harder.
Just
Friday's
Friday's
not way hard.
Friday's was easy. Today
Okay.
is really hard.
Either Friday or Friday. So, how do we add these together? Well, when you add fractions, the tops just get added together, and what happens to the denominator? Stays the same. What is sine squared plus cosine squared? It's one of our identities we learned today. What's sine?
Tangent.
No, sine squared plus cosine squared is 1. What's 1 over cosine squared equal to? Secant squared, which is what we're trying to get to. I automatically had it.
The whole problem was just secant squared.
Yeah.
Are you serious? They really had to write it like that? For secant squared?
Forces math.
No.
You should only go to
Can this be do never?
No, we'll just go to 16 though.
Yes.
Maybe I should make like 20 a bonus or something.
Yes.
Alright, you guys want to try 20, it'll be bonus.
So wait, are we not doing 17?
No, it's kind of like numbers 1 through 4. We don't need to do that.
What
97%.
You don't even
Stop.
You'll just have to wait with
Wait, so how do you
bated
get
breath.
6?
Ew, what is that?
You look at a square.
Like,